our world isn't just text, right? It's a crazy mix of images, videos, audio, all happening at once. So how do we get AI to actually understand all of it together? Well, let's dive in and break down the really clever tech that's making that happen. Okay, so here's the game plan. First, we're going to break down a foundational technique called RAG. Then, we'll look at what happens when you throw images and audio into the mix. That's the multimodal challenge. After that, we'll explore 3 different ways people are solving this, and by the end, you'll see exactly how they stack up against each other. All right, first things first, we've got to wrap our heads around the core idea here, Retrieval-Augmented Generation, or as everyone calls it, RAG. This is really the secret sauce that lets large language models answer questions about stuff they weren't originally trained on. So picture this. You're building an internal help chatbot for your company. An employee pops in and asks, hey, what's our latest VPN policy? The huge problem? The LLM has no clue. That policy is brand new, it's private, and it was definitely not part of the public internet data the model was trained on. So what do? And that's where RAG comes in. See, instead of this super expensive, time-consuming process of retraining the entire model, we just give it a cheat sheet right when it needs it. The name says it all. It retrieves the relevant VPN policy document, it augments the employee's question with that document as new context, and only then does it ask the model to generate an answer. It's a simple idea that grounds the model in facts. Okay, so how does this actually work? It basically happens in 2 big phases. First, there's the offline stuff you do ahead of time. You take all your documents, all those policies, and you chop them up into smaller pieces. Then, you use another AI model to turn each piece into a vector. You can just think of a vector as a long list of numbers that captures the meaning of the text. All those vectors get stored in a special vector database. Then comes phase 2, the online part. When a user asks a question, you turn their question into a vector too. The system then zips over to the database, finds the document vectors that are mathematically closest to the question vector, and boom, it grabs those chunks and sends them to the LLM along with the original question. So that all works great for text. But what happens when our data isn't just a bunch of tidy text files? That's where we hit a wall. We hit the multimodal challenge. I mean, let's be real. When was the last time important info was just clean text? Real-world data is messy. It's an interconnected web of documents, screenshots, diagrams, you name it. Yeah, let's go back to that VPN policy. I bet it has a network diagram in it, right? A user manual for a product is going to be filled with screenshots. You've probably got scanned PDFs of old contracts, video tutorials for new hires, or even audio recordings from important meetings. Your classic text-only RAG system looks at all that and just shrugs. It can't understand any of it. So the big question is, how do we get around this? Well, there are basically 3 main strategies engineers are using, and they range from kind of simple to really sophisticated. Let's start with the most straightforward one. Okay, approach number 1 is, well, pretty much exactly what it sounds like. We call it textify everything. The idea is to just turn everything into text and shove it into that classic RAG pipeline we just talked about. It's a pretty clever way to avoid rebuilding the whole system. So the workflow is super simple, right? You take an image, you run it through a captioning model. You take an audio file, you run it through a speech-to-text service. Now everything's a text file. You can just throw it all into your vector database and use your standard RAG setup. Seems easy enough, yeah? Well, there's a huge catch. This is where things start to fall apart. So much gets lost in translation. Remember our network diagram? A caption might just say something generic like, a diagram of the corporate network. But what if that diagram had a red line showing the main connection and a blue line for the backup? All of that crucial visual information, boof, it's gone. The text just can't capture that level of nuance. So that problem, that loss of detail, leads us right into our second approach. How do we get the best of both worlds? Keep the simple text search, but let the model see the full picture? This is what we call hybrid multimodal RAG. So the big ticket change here is what we actually send to the large language model. We still use the text captions to search for the right information, but when we find a match, we don't just send the caption. We also send a pointer to the original media file, the actual honest-to-God network diagram. Now the LLM gets the text description and the image, so it can see for itself that the red path is the primary one. But, and this is a big but, the system still has a kind of Achilles heel. The search part, the retrieval, is still 100% dependent on those text descriptions. If the caption for that critical diagram is just plain bad, the system might never find it in the first place. The retrieval part is still the bottleneck. So that's the million-dollar question, right? How do we fix that retrieval bottleneck? We need a system that can search the images directly, not just their text descriptions. And that brings us to door number 3, the most powerful and honestly the coolest approach, full multimodal RAG. Okay, so this is kind of the holy grail of what we're trying to do. Instead of forcing everything to become text, we use these incredibly powerful models that can map text, images, and audio into one single shared vector space. Think of it like a giant library map, where the idea of a dog is in the exact same spot, whether you find it by reading the word dog, seeing a picture of a dog, or even hearing a dog bark. A search for one can find the others, because their meaning is co-located.
The upside here is just massive. You get the richest, most accurate answers because the system can search and reason across all these different media types natively. But the trade-off is also pretty significant. This approach is way more complex and way more expensive to build and run. It's the kind of thing you'd use for high-stakes applications like medical diagnostics or detailed intelligence analysis, where that extra accuracy is worth every penny.
All right, so we've walked through all 3 solutions, from the simple and scrappy to the super complex. Now let's put them all side by side. This will make the pros and cons crystal clear. This right here is your main takeaway. First up, textify everything. Think of this as your quick and dirty solution. It's fast, it's easy to implement when you just need something working, but you're gonna lose a ton of detail. Then you have hybrid. That's your pragmatic middle ground. You get a much smarter LLM without having to rebuild your entire search system from scratch. And finally, full multimodal. That's your top tier, no compromise option when accuracy is absolutely everything. But it's going to require a serious investment in time and resources.
And all this really leaves us with one big question. As our data becomes more and more complex, more visual, more auditory, the need for these kinds of systems is just going to explode. So the real question isn't just which approach is best today, but which one of these paths will ultimately lead us to the next generation of AI, one that can truly understand the world in all its rich, messy glory, just like we do.